During last lecture, we have started with the fifth chapter that is related to display technology or display devices. Now, in that, we have seen some of the basics of TV. In fact, we also introduced TV is very similar to your monitor, operation of monitor, and different characteristics of display devices. Now, in continuation with this, I will explain you today related to the operation of LCD TV, operation of LED TV, and then we'll compare what is the difference between CRT and LCD as such. So to understand LCD operation, that is liquid crystal display TV, you need to understand what is polarization. So here polarization is the orientation of electromagnetic waves. Normally, if you consider light is which normally say it is a polarized. That means the light consists of electromagnetic waves, and these electromagnetic waves are oriented in different directions. Especially light, we normally call it a random polarized light. So if this is a random orientation, then how this polarization is used in LCD TV? So for that matter, if you take a simple experiment, if you use a special filter and if you allow light to pass through some special filter, the filter blocks all the light except that have certain polarization. Now, one you may say, in most of the times, probably you might have understood the polarization concept related to antenna. If you see how the waves are transmitted from antenna, normally these are either horizontally polarized or vertically polarized. When I mean horizontally polarized, that means the direction of orientation of electromagnetic waves are horizontal direction, or it may be vertical direction. So when two polarizing filters are placed, so a ray of light may pass through both of them. Then the amount of light transmitted depends upon the angle of polarizing filters with respect to each other. Now, how here to understand this polarization effect, it is very useful. In fact, liquid crystal display, that is one of the type twisted pneumatic displays or TN displays, actually uses the polarizing filters which are used in conjunction with special liquid, and actually it helps to brighten or darken the region of the display whenever the external voltage are applied. In short, we have to understand what is the polarizing effect and how it can be used in LCD TV to make certain portion on a TV bright or to make certain portion as a dark. Excuse me. Hello, can you hear me?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
There, there was a
Yes,
call
sir.
from
Yes, sir.
related to examination. Anyway, uh, let us now see this particular picture where if you see, this is the actually vertical filter, and through this vertical filter, when light has passed, then whatever the if a light is polarized or vertical light is polarized, that means if light is direction of light is vertical, then only that waves will be passed, remaining will be blocked by this vertical filter. Similarly, if waves are horizontally polarized, then that will be filtered by horizontal filter and the remaining waves can be blocked. On similar line, if both the filters are kept adjacent to each other, then it will almost block all the horizontally polarized or vertically polarized waves, and there will be almost no output across the filter. So this is the effect of if you use a light filter. Okay, now here let's come to what is the LCD display. So as the name indicates, it is a liquid crystal display or LCD displays. It draws the definition. Why it is called liquid crystal display? Because it is a combination of two states of matter, that is solid or liquid. I mean, it is neither a solid or not a liquid. That is why it is called as a liquid crystal display. Actually, LCD uses a liquid crystal display to produce visible image. Whatever the image you get, it is actually the property of LCD display. The liquid crystal displays are super thin technology. This is very thin, and it is normally used in the screens of laptop, computer screen, TV, cell phones, and other portable video games. The basic principle of liquid crystal display is it is actually blocks the light rather than emitting the light. So LCD blocks. Remember, this is the principle of LCD. It blocks the light rather than emitting the light. And just without a light, it is not possible to display anything. So the LCD requires a backlight as they do not emit the light by themselves. LCD never emits the light. That is why we require to have what is called as a backlight. That is the light of source that actually used to emit the light. Now there are two types of displays. If you see LCD, there are transmissive displays or reflective displays. There are two types of LCD displays. As I said, one is transmissive, another is reflective. When you say transmissive LCD type display, it is illuminated from the back by a backlight and viewed from the opposite side. That means at the back side there is a light of source, and from the front side you have to view the things. This type of LCD is used in application like computer displays, TVs, mobile phones, and all these everywhere. This is transmissive LCD type is displayed, where you will have at the back light of source, and from the front side actually we view the image. Then here their power requirement is more in this type of display. When you say reflective type LCD, probably you might have seen this type of displays mostly in watches and calculators, where illuminated lights, where these watches or calculators are illuminated by external light reflected by a reflector behind the display. That means light is directly incident onto a reflector, and then it requires a very low power, and hence it larger and longer battery life is there for such type of devices. So again, there are two types of LCD displays. As I said, one is transmissive LCD display, another is reflective LCD display. We are going to cover a transmissive LCD type display. Now, liquid crystal display, commonly abbreviated as LCD, is a thin flat display device made up of any number of color or monochrome pixels in front of light source or a reflector. That means there are many pixels are arranged in front of light source or a reflector. As I said, liquid crystals are neither a solid nor a liquid. Liquid crystals are substances that exhibit the properties between those of conventional liquid and those of solid crystal. Let us take an example of what is polarized light. To understand this, best example is your sunglasses. If you have a now why we use the sunglasses just to prevent your eye from the intensity of light. Actually, by using a sunglasses, you can have a pleasant viewing. That means intensity of the light can be dropped. How it is possible? How it is dropped? Now, if you put one pair directly in front of the other, you still be able to see the through. That means if both the glasses, sunglasses, if you put one above the another, rather if you take one simple sunglasses, then if you just see towards the sun, then you will find that because of it acts as a filter, it actually reduces the intensity of light by blocking some of the wavelength or some of the polarized light. Now, if you really want to go ahead, if you have two glasses and if you put these two glasses one above the another, still you will be able to see something through it. Let's see, if you have one simple glass and if you try to rotate that particular glass with the another glass keeping above it, that means you have two sunglasses. One is fixed and above it if another is rotated, then you will find that slightly the light that is coming from will become darker and darker. That means what happens here, the light is blocked. Now when the two pairs of sunglasses are exactly 90 degrees to each other, you won't be able to see through them. That means they have blocked all the lights coming through it. So what is important in this experiment is that if you have two filters, with respect, if both the filters are 90 degrees with each other, then they will block almost all the lights and almost no light will come through. That is the basic principle of LCD, or that is the basic principle of polarized light. This principle we normally used in sunglasses. Let's see. Now here, as I have explained you, if both the pairs of glasses are pointing in the same direction, that's fine. That means light will be vibrating vertically and still again that can get through. But if you turn the second pair of glasses through 90 degrees, the light waves that made it through the first pair of glasses can no longer make it through the second pair. That means it will block. No light at all can get through the two polarizing filters that are 90 degrees of one another. Remember, this is the basic principle which is being used in LCD TV. If you have two polarized filters which are kept exactly 90 degrees with each other, then almost all the lights are blocked. That is why we say the principle of LCD is blocking the light rather than emitting the light. Let's see, now we'll see what is exactly the LCD construction. The figure shows this particular construction. If you carefully see this particular figure, then you will find at the back of the at the back side you will find there is a mirror. Let us say this mirror is A, which is a reflective mirror. That means whatever the light source incident on this, all the rays will be reflected. Now this rays reflected, if you see the construction of this, then just below, just in front of the mirror, we'll find one glass filter named, let us say that is B. That glass filter is normally covered with one polarizing film. And if you see this particular picture, you will see that these yellow lines, vertical yellow lines. That means this is the vertically polarized filter. That means it will allow the lights which are only vertically polarized. It will pass through that particular polarized film and it will incident on this particular glass filter. Just on this particular glass filter, on other side of this, you will find there is a negative electrode C that is made up of indium tin oxide. It is on the top of this. That is, you can say the pink colored portion here in this figure. This is the indium tin oxide. Now that means on this, if you see carefully, again the same structure will be there on another side. If you see this particular green colored block, this is it is actually your liquid crystal display. Okay, so this is liquid crystal display. On of this liquid crystal display, again you will find very similar to like glass B, there will be a glass E. Again, or to attach to this glass, you will find one polarized film, that is again polarized film F is attached to this glass layer. In this case, you will find this polarized film is horizontally polarized as against to the glass filter, which against the this polarizing film which was vertically polarized. And then here, if you see now entire structure, let us say this structure is again shown over here. Now if you see this particular structure, exactly at the center you will find there is a liquid crystal display. On both the side of a liquid crystal display, there are two electrodes shown in pink color. So one is negative electrode, another is positive electrode. Then on nearer to the immediately electrode, you will find there is a glass filter on both the sides. And to these glass filters, then two polarizing films are attached to it. On the left side or on towards the mirror side, it is a vertical polarizing filter. On towards the front side or display image side, there will be a horizontal polarizing filter. If you just try to remember this particular figure, keep in your brain this particular figure, because this figure we are going to use to understand the operation of LCD. Again, I'll repeat this operation. Here, as I said, at the center portion, you have a liquid crystal. On both the sides of the liquid crystal, there are negative electrode and positive electrode. Then, to nearer to their electrodes, you have glass filters on both the sides, and to these glass filters you have polarizing film, that is vertical polarizer is on mirror side and horizontal polarizer is on your display side. Then at the extreme end, at one end you will find a backlight that is a mirror, and front end that is actually the image that you actually see. So this is the construction of this. Let's see how it works. An LCD TV screen uses the sunglasses trick to switch its colored pixel on or off. As I said, LCD TV best whatever the sunglasses trick which we have already seen. If you make your two glasses exactly 90 degrees apart, if you use two polarized glasses, and if these are kept 90 degrees with each other, then we have seen that it can be used to switch the light on or off. Similarly, you can make your pixel on or off. That is, now at the back end of the screen, there is a large bright light that shines out towards the viewer, that is called as a backlight. So simply, in other words, backlight is a light source. Probably if you have a broken, if there is a broken mobile or a LCD display, probably you may be able to see even that backlight from your mobile phone or even some part of this. So that is more important. Its backside, it is called as a backlight, that is a light of source. Then in front of backlight, millions of pixels made of small areas are called subpixels. Each pixel is colored as red, blue, and green. Again, for each pixel, there has a polarizing glass filter behind it as well as in front of it. And both the polarizing filters are placed exactly at 90 degrees. Makes the pixel normally looks dark. Now, if this is the position, then for normally you will find pixel will always look dark. In between the two polarizing crystal, there is a tiny twisted pneumatic liquid crystal that can be switched on or off, that can be twisted or untwisted electronically. When I mean say twisted, that means they normally in normal state LCD, that is pneumatic displays, are in untwisted state. But if you apply certain potential to this, then this gets twisted. That becomes what is that it becomes twisted. That means this straightens in a horizontal direction. So I hope now you remember this particular feature. Now you have at least in brain, or you can recall this particular figure when I am trying to explain you the operation of LCD. When it is switched off, it rotates the light passing through it through 90 degrees, effectively allowing light to fall through a two polarizing filters and make the pixel look bright. That means whenever your pixel looks bright, that means there is no, uh, this means that you have applied certain voltages. That means you can switch off the LCD or you can switch off the pixel whenever you pass certain lights through this. That means you have to apply certain voltages. When it is switched on, that means it doesn't rotate the light which is blocked by one of the polarizer and pixel looks dark. Remember, each pixel is controlled by a separate transistor. Later on, I'll show you what is the construction of a transistor, that is passive matrix display and active matrix display. But remember, each pixel is controlled by separate of transistors. Now, at this stage, what you have to imagine is that if you have let us say if you have a laptop screen and if you say that it has got HD resolution, that means certainly there will be 1920 pixels in horizontal direction and 1080 pixels in vertical direction. When these many pixels are there, each pixel consists of RGB colors. That means there will be three dots or three colors will be there for each pixel. Now, how these particular colors are being now for these three pixel colors, every pixel will have one thin TFT transistor, which is actually controlling or which will actually allow the either it will make the switch on or it will make the switch off. Now, how this switch on and off is made, that can be simply or simple operation of this LCD can better be understood from this particular figure. Let us say we'll see how pixels are switched off. As I said, there can be thousands of pixels onto your screen. Let us say if I wanted to make all pixels off, that means when I made all pixels off, obviously there will be dark at the front side of your LCD panel. Now let's see how one single LCD gets switched off. That means if one position of LCD is off, you will have a very tiny dot. If you have a white LCD, and if you just try to control the center pixel, and if you wanted to make it black, how this can be made black? The principle behind is this. The very first step is that if you see the very first step, it actually emits the light. That light is coming from source that we call as a reflective source, or that is a backlight source, which is actually giving the light. Now, if this light is going, let us say that now this particular light is, let us say it is horizontally polarized. If this light is horizontally polarized, then as the filter is horizontally filter, then all the light coming from this, it will be passed through the windows as shown in the second. Then what will be this particular light? It is horizontally polarized. The direction is horizontally polarized. So that is why what will happen? It will come as it is. Now, as the pixels are switched off, now what will happen when the pixels are switched off? That means there is no potential applied across your LCD. When that means these are in natural state. When these are in a natural state, at that time, whatever the light that is passing through this particular LCD, it is actually twisted by 90 degrees. So whatever be the now, whatever you have this, but now because of this, what happens? Now this is being so whenever these pixels are switched off, at that time, see here in figure 4, you will find this normally light, what will be there, this is will remain as it is. As you apply certain potential, because of applications of potential, you will find that the LCD will be in what we call as an untwisted state. When it is in untwisted stage, the whatever the horizontal light polarized, that will pass through this pore as it is, and it will be seen as it is in the film. That means you will find this horizontal polarized light which is coming from the light source, because the LCDs are untwisted because of the potential applied to the LCD. Due to this potential, the horizontal polarized remains as horizontal polarized, just like 3 and 5, this will be same. As the waves are horizontally polarized, then when it is passed through vertical filter, entire thing will be blocked and nothing will come out. And in that way, that particular pixel will be shown as a dark. Remember, I'll repeat this again, I'll repeat the operation of same. That is, we are discussing how pixels are switched off. That means if any pixel is there, then how this is switched off, or how viewer you see this is a off condition, that is a black condition for that particular pixel. So that is possible because the light is coming from your backlight. That light source, as this is horizontally polarized, then all the light except horizontally polarized, everything will be blocked by horizontal filter. Only horizontal light will be allowed. Then third 3 shows that this is horizontally polarized. Then at this stage, when this is horizontally polarized, at that time, if you want to make this pixel off, you have to apply the potential across the LCD. When certain potential is applied across LCD, that pixel gets straightened up. When this gets straightened up, that means horizontal waves are passing through it. Then when it is passing through it, these are not get twisted, and then horizontal is incoming to LCD filter. This also pass without any twisting to it. So horizontal remains as horizontal. When this horizontal passes through vertical filter, actually because of this property, it is going to pass only vertical waves. It will block all the horizontal waves. As all the light is blocked by 6, nothing will be able to see on C7. That means that particular pixel will be off. On similar lines, so this is the procedure what I have explained you in first to 7. This is given here. If you any confusion here, you just read it, you'll understand very clearly. Now next comes to how pixels are switched on. That means we are going the reverse procedure now. If let us say if this entire screen is dark, and if you want to make your one pixel brighter at the center point, then how it can be made brighter? Then the procedure for this is that again on first side the backlight will emit the light. Horizontal will only allow this horizontal light to pass through it. When this is horizontal light is at 3, it is shown here. Now here you will not be applying voltages across LCD. That is pneumatic display or TN display, that is twisted pneumatic display. When there is no voltage is applied across this will be in its natural state, that is twisted state. And because of this, whatever the light coming horizontally, it actually this the property of this is that this automatically twist the light by 90 degrees. Then whatever the horizontal light, those were passed through this LCD display, it actually rotates that horizontally light into 90 degrees and makes that vertical. That is why you will find here when you see this third waveform, this is horizontally polarized. Now this becomes the vertically polarized, and this horizontal polarization converted into vertical polarization due to the natural property of LCD, which actually uh, which is actually in untwisted form, or sorry, it is actually in twisted form. That is why there is a 90-degree phase shift between this horizontally polarized wave becomes vertically polarized wave, and these vertical polarized waves, now when coming to this vertical polarized filter, actually this is passes through this. That means entire light what is emitted from one, that comes as it is to through both the filters, and it is directly incident on this particular RGBs, and immediately this particular light glows. Now whether if it when I say it becomes red, that means only the red light is coming and it is incident onto this. When you have certain G, that means when only G, when it is incident, or when this particular light or the intensity is respect to only G, then it will be focusing only on to G. But if you want to have some millions of color, how these millions of colors will be produced? That will be dependent upon the what is the intensity of RGB. And that intensity of RGB, now you know, this is normally your, mostly it is a digital signals. If you use certain connectors, or even it can be your VGA connector where it has got analog signals. Then whatever the RGB signals are coming from this particular connector, then actually it will hello. आता हे बघा की now how these pixels are switched on. This color will entirely depend upon the content of RGB. If this is purely red, it will be red. If it is purely blue, it will be. That means B is 255 and R and G are zeros. Then in that case, this pixel will be shown with a dark blue color. Then depending upon the content of RGB, accordingly this 7 will be of a different color. Okay, now the same procedure, how pixels are switched on, again the same procedure is given over here. Now whatever I have explained you, I can also explain the same thing by another diagram. Now if you see here, this is a vertically polarized filter and this is horizontally polarized. Okay, can you hear me? Hello?
Yes, sir.
Okay,
Yes,
fine.
sir.
Yes, sir.
Let us now I'll try to explain you LCD by another way. Now see, these are the two filters. One is vertical filter, another is horizontal filter. Now in between what you see, this is actually LCD or pneumatic twisted display. Okay, this is we call a LCD display. Now let us say when the electric field is applied. Now when electric field is applied, actually because of electric field applied, it loses its what is called as a twist. It loses twist means that becomes straightens. When it becomes straightened, then this all vertical filters will now whatever the image that is going through this, then in that case you will find everything will be passed as it is and nothing will be blocked. That means vertical if a vertical light is coming, that vertical will pass as it is, because as LCD becomes straightens, then in that case as this also becomes vertical. So they in other words, your vertical light is not blocked and it comes as it is. And because of this, you will find there will be a blocking. When vertical light is passed through horizontal filter, everything will be blocked and nothing will be able to see on outside. But if you see this particular, this is a very good picture which will give you the idea that let us say this is a vertical light coming through this, as this is in untwisted form. When there is no voltage applied across LCD, this is a natural state. And because of this natural state, your light is twisted by 90 degrees. If this is vertically polarized, because of this, it will become horizontal polarized, and when it is coming at the end of this horizontal polarizer, it will come out through this and your pixel will be brighter here. Hopefully now you understand the operation of this. Another way, the same thing I'll try to explain you with another picture. Now see here what is happening in this case. Now if you see this particular here, see this is, let us say this is vertical light inside the vertical filter. When it is coming here, because of this is no voltage is applied, it is an untwisted form. So what this vertical lines get twisted by 90 degrees. In fact, it is shifted by its angle is shifted by 90 degrees. Because of this 90 degree, this vertical becomes horizontal, and when this horizontal coming through this horizontal filter, everything will be there outward. That means whatever the light here, this light will come out as it is without any blockage from this particular point. So at this particular stage, we say that LCD is in it's in normal state, that is in twisted state. But when, let us say, if you want to block the what is off state, in off state, what happens when this vertical light coming through this, when you apply the voltage to LCD, this is becoming straighten up. When this, because of voltage, it gets straighten up, the waves without any shift or without any it is not shape, it is not, light is coming as it is to this particular plate. So this is vertical, it is remains vertical, and when it is applied to horizontal plates, everything is blocked over here and nothing comes out. So this is the principle of LCD display. Hope you have understood now by these 3-4 diagrams. You can, and basically again in short, if I want to recall everything, as I said, for LCD works on the polarized light principle. When you say polarized light, that means the direction of orientation of electrical signal, mostly electrical and magnetic signal that we call as the electromagnetic waves. Normally, light is a random, right? Light signal is random in nature. But if you use the filters, that is vertical and horizontal filters, and if you keep one horizontal and vertical, a basic property of LCD is that it is always in liquid form. It is neither, as we said, solid nor a liquid. But when you place that LCD and when certain light is passed through it, because of its twisting nature of LCD, it actually shifts this light by 90 degrees. And because of this, if you want to allow, this makes you to allow certain light to pass through, or it is also possible to block the light. That is why we say LCD works on the principle of blocking the light rather than emitting the light. Hope you have understood now what is the basic principle of LCD. Let's now, what are the that things we have seen in our discussion? What is the backlight as such? So backlight is always a light source. It is a very high intensity light source. It is a, in fact, see here, there is a certain arrangement, light and light guide. There is a diffuser, then prism film is there. With this reflective polarizer, though it is a source of light, but light is evenly distributed across the LCD panel. Now, if you see this LCD panel consists of all the pixels of RGB very nearer to each other. That means if I say I have a resolution of something like HD resolution, when you have a HD resolution, you know that it is 1920 by 1080. That means 1920 into 3 pixels are there on horizontal side. Why I say into 3? Because 1 pixel for red, 1 pixel for green, 1 pixel for blue, and these three actually forms one complete pixel. So there will be so many pixels will be there as in the form of like phosphor, whatever we say phosphor dots on similar line. This will be nothing but then these are the pixels and which are electronically controlled. So whenever there is a light to be shown, then if the certain voltages are applied. Now, which voltages will be applied to the, how this will be controlled? As I said, we are applying certain voltages to the LCD. Then which voltages is applied? Which you apply actually RGB voltages. Depending upon the signal strength of R, G or B, this is actually applied to the thin film transistors. And based on the signal, it gives, this is actually decides how much light or how much twisting will be there for LCD. Then more the light, then there will be more untwisted. That means this will become more straight. If you have a brighter the intensity, then in that case what will have, it will twist that entirely 90 degrees and it will pass through it. So this is this way, depending upon your intensity of LCD, it will automatically twist. So see, this is another waveform of backlight, which you say this is a light source, and this light source is were actually put onto this reflective polarizer, and from this then this light is coming into a parallel direction. So let us say this is entirely, this is a backlight. The light coming out of this backlight is uniform and it is in horizontal direction. So whatever be this particular direction, this particular light now will be applied into the polarizing field. So this is all about backlight. Then when I say passive matrix display, so if you see this, but this is the arrangement of pixels and how this is connected to the pixel. Now, if you see this particular passive matrix display, there will be two rows of electrodes. One will be horizontal rows and another will be a vertical rows. See, these are the all, this is arranged in the matrix form. So you have horizontal rows as well as you have vertical rows, and you have a cross section of horizontal and vertical. And based on the some complex mechanism, complex electrical waveform, actually it controls the differential intersection of these electrodes. And based on this, what will be the row and column voltages, that actually decides the intensity of this particular pixel, and it is actually directly proportional to the original color. So this is the intersection of the columns, rows and pixels. So this is passive matrix display. It is normally used for a low cost display. If you have a high cost display, then normally we use what is called as an passive matrix display. This or sorry, we use active matrix display. In this active matrix display, see, this is actually each pixel. Again, this pixel, how it is organized, it here it will find there is a capacitor, gate line voltage, supply voltage, and here this is entirely, this is the construction of one, and this is lighting of this is actually controlled by chip, controller chip, and this controller chip actually controls the film thin film transistor, that is TFT. So this is as this is being an integrated circuit, and for each pixel there is a one thin film transistor. Each pixel, I mean, either it is a red, blue, or green pixel. For red, green pixel, there will be three thin TFT, and that is actually controlling the glowing of that particular RGB. And ultimately, based on the input, whatever the signal strength, input signal strength, relatively exact output you will get from this. So this is active matrix display. Now this picture shows what is LCD panel. So as I said, LCD panel again consists of the whatever the earlier picture, same picture you can just think of. What I said is in between you have a LCD. Then from both the sides of LCD you'll have a positive electrode, negative electrode. Then nearer to the electrodes you will have a glass substrate, and above then nearer to the glass substrate, on a glass substrate you will have two polarizing plate. One is vertically polarized, another is horizontally polarized plates will be there. And after this polarization plate, one side will be a backlight and other side will be your front side, or what we cited display screen will be there on the other side. So based on, depending upon your RGB signal, accordingly the intensity, actually LCD controls which lights to be passed and which lights to be blocked, and that is entirely controlled by giving the signals to your thin film transistors, and by operation of thin film transistor you automatically control the entire operation. But this operation is so fast and so quick that, yeah, all these LCD, all these pixels are instantly lighted, and instantly these are made of. And this way your LCD panel works. Now you might have a question that now if you see the screen TV, or in most of the displays that are coming in the market, you'll find now LED has swept almost all the displays in the market. Even very rarely you'll find LCD displays, because it is found that there are technically, and even by, if you see the resolution and quality of this, LED is far superior than LCD, CRT, plasma, and other display techniques. Now, how this is now, the you might have a question that what is the difference between LED TV and what is the difference between LCD TV? So the basic difference between LED TV and LCD TV is the light source. If you see the light source of LCD, this is normally uh, cold CFL, cold CCFL. Normally say cold. When you say CFL, that is cathode fluorescent light. Now we use the CFL tubes or CFL bulbs. That is cathode fluorescent light. Okay, and that's if this is cold CFL tubes, that light is used in the LCD displays. Now instead of this, if you use the LED as a light source, that is a very bright light source. Rest of the operations, you will find the rest of the operation is same. Now if you see this particular image, then in this particular image you will find LCD is always there, because LCD is used to make either on or off the light. Then which light is to be passed and which is to be blocked? Then this light is, instead of coming from CCFL, it is coming from LED source. So if you see TFT and electrodes, now here thin, now if you see, now let's see here, this is the backside. That means LED backlight is there. For LED TV, the backlight used is LED. For LCD TV, the backlight used is CCFL. That is the basic difference between LCD TV and LED TV. And as you have a very strong and intensive light that is coming from LED, its clarity is very, very good compared to. Then again, you will find, see, there is a polarizing filter. So if you have a horizontal polarizing filter, then you will have another vertical polarizing filters over here. So these are the two polarizing filters these are used. Then this is TFT and electrode, that means thin film transistors are there, which actually gives the supply or apply potential to this LCD. And based on this potential, the degree of twisting is decided by the applied potential to the LCDs. Then here you have RGB filters. Then RGB filters, when exactly this is incident on this corresponding RGB, then you get certain light, and that light is illuminated in front of this. So this is the way how LED works. So this is the LED working of LED is given. LED are again of two types. LED, probably you may have a one strong light emitting diodes at the back, that is a what we call as a LED backlight, or sometimes you will find there are certain LEDs which are being placed in front of the TV, that may be that may be placed in arrays, or most of the times the LEDs are placed at the edges of the screen. So that is depending upon how this particular is placed. So LED works, as I said, LED is a far better option than the LCD option. Then in what is better option? Why? Because LED has got a very good viewing angle as compared to LCD. If you see any picture on LCD TV and if you see any picture on LED TV, even if you see across this or from corner, even you will be able to see a very good quality picture without blurring it. But if you see towards LCD, then you will find the picture will be blurred as it has got a poor viewing angle. So this is all about this. Now finally, we will just compare about LCDs and CRTs. What are the pros and cons of both the TVs? Let's say very first point is slim factor. That means how slim is. As you know, LCD you can hang on the wall also. It is very slim. And if you talk about CRT, it is going to be bulky because it is required to have certain minimum size for the picture tube. That is a neck of the picture tube, which will be at least 0.9 inch. Or there are some thin CRTs were developed, but that cannot compete with the LCDs. Then viewable screen, full or very close. You can entirely see screen is visible to you. Usually zero point 0.9 inches or less than actual size. The entire you cannot see CRT because some of the portion you have to block it, and then even in the you have to have some extra lines are there beyond your width. You have to scan those particular. So here only 0.9 inches are available as actual size, and remaining is packed into front side. Then screen flatness is concerned, it is a true flat. This is a fake flat. Fake flat, I mean, those there are certain advantages by certain companies that they have CRT as a flat CRT. You might have seen 10 years back, this was the advertise for CRT, flat CRT screen. It was not practically flat. They have made it actually look like a flat because by certain adjustment in and allowing the CRT to go at the extreme corners, and so that entire picture will be uh, equal. It entire picture will feel like it is a flat, but it is not a true flat. Then radiation, it is very little or almost no radiation from LCD. There is more radiation from CRT. As far as weight is concerned, it is lightweight, it is heavy. Power concerned, it is very low power, almost 250% or more power. That means if your LCD is working, if probably if you see LCD TV or LCD monitors, etc., this is hardly takes 15 or 20 wattage. But if you take a CRT monitor, it will take about 50 to 70 wattage. Then glare, there is no glare, so your eye will be protected from it. There is a reduced glare. That means you can reduce certain glare from CRT. Then image sharpness, it is a very sharp image for LCD compared to the slightly less sharp images in CRT. Automatic resizing is perfect. This is not a perfect, imperfect is there. If you say burn in, there is no question of burning in LCD. But if you continuously keep your CRT on without this, and then in that case, certain portion of the CRT may get burn. So that is why you will find in most of the TV screens there will be a dancing what we call as a screensaver is there, and that because of screensaver there that CRT beam is all not instant on the same pixel continuously, and that actually saves the time. That is why it is called as a screensaver. Then refresh rate, no refresh rate, 60 hertz is fixed. Then here needs a refresh rate minimum 72. That means larger refresh rate is required. Warmness, it is less little, almost your skin never becomes hot. LCD, oh yes, it does become hot, but not too much. But it gets very warm after certain time. CRT. Then dead or stuck pixel, this is a problem with LCD. You might have noticed if there is certain damages to your LCD or some part or some portion is damaged, that is your integrated circuit, then you may have a dead or stuck pixel, which will be always look like a dark bright color black spot. No such a problem in CRT. Response rate, there is a slow response rate. No issue with the response rate. Response rate of CRT is much better. And price, now we may say expensive and cheap, but by the time when nowadays, I'll say because of the large and mass manufacturing, almost LCD and LED are came at the same prices at that of CRT. Rather, because as nobody is going using CRT, and this is not found to be suitable now as for display, and whatever be the LED in the market, that is why that is you it is available at a cheaper rate. But if you go for new one, you will not get new CRTs in the market, at least as a display devices. Then native resolution, as a native resolution, there is no none resolution. Native resolution means what? As you know, on your display panel with operating system, you can set your resolution. Whether this resolution should be HD, VGA, Super VGA, or maybe HD, or double HD, or UHK, it is up to you. Okay, so you can decide what should be the resolution of your TV. So that is what we call it has got a native resolution, which it is software controlled. So you can decide what should be the resolution of this. Then maximum color, so you can have 16.7 millions of color, and CRT has got 32-bit colors. When you say 32-bit colors, you already know 3 bits, 32 bits means 4 bytes, 1 byte for R, 1 byte for G, 1 byte for B, and 1 byte for brightness, that is either blue, either black or white, or in between gray. So this will decide the actually the intensity of each color. Then weaving angle, it has got a narrow weaving angle, and this has got a wide weaving angle. That means CRT, on CRT you can see from any side, you will be able to see a good picture. But LCD has a narrow weaving angle, but LED has overcome that particular problem. LED has got much better, wider viewing angle compared with the LCD. Then video, not ideal for videos unless HD. As now all you are working with the HDs, and you are also experiencing the operations of with the resolution of HD, how good quality pictures you get. If you have got HD or 2K or 4K, then the quality is unmatched quality, you can have video. But here ideal for any video viewing including HD. This is good for viewing, but this is costly. Blackness between dark to gray, that means here you will get a true black in CRT. That means exactly black color, dark black color is possible to get in CRT, but in worst case it is very tough to get the dark color in case of LCD, because some of the lights get passed through horizontal or vertical filters, and because of this exactly dark gray you can get, but you cannot get exactly blackness in this type of LCD. So this is all about the topics that I wish to cover today. So now today what I have explained you, it's something like what is the operation of LCD. Again, I repeat, the operation of LCD is based on the polarization of light. Then polarization of light means this is the orientation of electromagnetic waves, whether this is horizontally polarized or vertically polarized. And based on the proper filter, it is possible to prevent the light, either which is we can block the light which is horizontally polarized or vertically polarized. Then we can use LCD. LCD is a one type of say what we can say material, that this particular material is actually allows you to block certain light because this is a crystal display. This is a twisted display. Natural condition is twisted, and whenever the light passes through it, it automatically twists that particular light by a 90 degrees. That means any horizontal waves, horizontally polarized light that can be converted into vertical polarized light. And then you have to decide which how much is to be passed and how much is to be blocked. Then that will be decided by the original intensity of that. And because by applying that particular potential, the LCD will be automatically twisted or untwisted or proportionately twisted. And accordingly, you will get the bright light or a darker light. Then at the end, we have seen certain construction of LCD. Then what is the operation of LCD? Then what is a passive matrix display? Maybe what is the backlight concept? That is a light source. Then maybe what is the now even if you can see if there is a if your display is somewhat torn or I mean say it's broken, then in that case you can also see the very high intensive light from backside, that is from backlit. Then what is active matrix display? Passive matrix display. Then later on, we have just compared what is the differences between LCD TV or a LCD display and CRT display. Now next time in the tomorrow's lecture, I will cover you of related to video driver. That means how exactly your video signals are taken into RAM and how from this RAM it is converted into RGB given to your VGA terminals, and then how this VGA actually is responsible. Later on we have seen actually once the signal comes to VGA, later part we have already seen now, because VGA contains three analog signals, and these three analog signals when given to the appropriate display devices, then the rest of the display part is taken care. Now we have to just see how this actually your data or your text is displayed as a text and your images are displayed as images, photos are displayed as a photos. So that principle of operation that is controlled by your video card, video driver. That can be onboard video driver or it can be external video driver. So that tomorrow we will see the operation of it. So if you have got, as usual, if you have got any problems, your problems are welcome. So if you have got any difficulty, you please ask.